Hello, Aurora lovers. This is DaleBoan from DaleBoan Imaging, and this is Aurora Hunting 101. This is episode 27. Is that Aurora? When new hunters start out, they are often uncertain if what they photographed is actually Aurora or not. And to be honest, this can happen to experienced photographers as well. I have a bit of a checklist that I go through to try and determine if what I'm seeing or photographing is actually Aurora or not. Let's explore. So this is a basic checklist. There's probably some exceptions and it could be expanded in some ways, but this is certainly a good starting point. Sometimes the picture is just so marginal that you really can't tell one way or another. One of the ways of resolving that is to just wait and see how things change. But if you're just going from a picture, sometimes you just can't tell. But in general, for a photograph, we want to check to see if it was taken looking north. Sometimes have people with photographs facing south, and they're asking if it's Aurora, and it's probably not. If there's a bit of Aurora in the south, you should be able to see Aurora all over the sky, unless you're in the southern hemisphere, and then of course the Aurora's in the south. But for the northern hemisphere, they start in the north. They're marginal in the north. If they're covering the sky, it's usually, you don't need to ask the question. And is it dark? It needs to be dark to see the Aurora, or very deep twilight. If it's really, really strong, you can see it in reasonably bright twilight. But generally, it has to be pretty dark. I saw a picture recently. Somebody posted and say, "Hey, I've managed to photograph Aurora," and it's like, yeah, it's late afternoon. They provided the timestamp from the picture, and it was late afternoon. It's like, it's daylight. That's not Aurora. It's just a color artifact in the picture. So they should be showing a greenish yellow, yellowish green color, depending on the color balance of the camera. And then the best case is if there's sort of a red, magenta, sometimes purple color band above that. That's a really good indication that it's Aurora. And it should look like Aurora. Like, Aurora has a structure. It's not just a random thing most of the time. Sometimes if it's fairly high up in the sky, it can look pretty random, especially when it's starting to fade. But usually if it's just on the northern horizon, it's in an arc. There's a green layer and a magenta layer that might not be visible. The magenta might not be visible to your eyes, but it'll probably show up in a camera. Not always. It doesn't always have to be there. Was Aurora likely to be visible at that time? Sometimes you photograph the Aurora from, you can certainly photograph Aurora you can't see. Sometimes you can photograph them quite a bit further south than you might expect to be able to see them. But in general, if it's really weak, you're not going to photograph them in Oregon, for example. They're just not going to be visible that far south. And can you see stars? This is when you start getting into clouds and things like that. If there's green, but you can't see any stars, it's probably just clouds, especially thick clouds. The Aurora aren't solid. You should be able to see stars through them. And then finally, if there's lots of clouds, it's probably just lights from the ground lighting up the clouds. In that case, it's typically not green. Sometimes there's green lights, especially now that we've got lots of LEDs. But generally it's a yellowish color if it's city lights. So let's look at some examples. Come on, let me scroll down. So I took this actually this week. And I went out because the forecast looked like there should be Aurora. And I saw this sort of glowy part on the horizon, and there is a moon behind me. And sometimes the moon can create sort of an arc on the opposite horizon. And I thought maybe that's what this is. You can see that there's some structure. Looking at it just on my camera, I had pretty much convinced myself that this was not Aurora, but you can see some bands here. It's approximately the right direction. There might even be a little bit of magenta above there, but it's pretty marginal. So I thought, yeah, it's probably not Aurora. And then a few minutes later, this happened. We started getting more structure into it. There's a little bit of a ribbon that formed. And then, okay, so obviously it is Aurora, despite having moon and a bit of smoke obscuring it. It turned out that it was Aurora, and it just got better from that. This was about just before 11 p.m., where I live. Peak time is about 1 a.m., 1:15. This one is one I've often wondered about. There was fog and smoke on the horizon. So the conditions are not good. But there's this band here. And I'm not convinced that that's Aurora. It could be just an artifact, but it could be Aurora. This was taken fairly far south. It is, if it's Aurora, it's my only Aurora picture from North Dakota. It's just taken just outside of Minot. I was on a trip with a new camera and decided to go try it before going and taking pictures of the eclipse with the brand new camera. And I'm still not convinced that is Aurora. That's too marginal for me to say for certain that that is Aurora. So if you have clouds in there, so this is definitely Aurora. But you can see here, if you got solid clouds, you can't see the Aurora, right? This solid band of clouds is obscuring the Aurora, and you can't see stars through it. Up here, you can see the stars through the Aurora, and you got a little bit of purples along the top here. So that's definitely Aurora. You know, below here, you've got the lights glowing up. In the distance, you got some lights lighting up the clouds from underneath. Not Aurora. If that was closer, it would be higher up in the sky. This is also a wide angle lens, so it's showing a very wide area. If it was a lens that like a 50 millimeter lens or something, it would be narrower, and that would appear to be closer. So you got to watch out for that sky glow from light sources, and it doesn't need to be a lot of lights there. That could be a couple lights causing that much light glow on them, on the clouds there. You know, and you've got some different colors here. We've got blues and yellows from the different light sources on the ground, lighting up the clouds above. So this is a panoramic image. It is taken looking at least partially north. That's the bowl of the Big Dipper, those 4 stars. So the North Star is probably somewhere up here. And there's some bands of Aurora in here. They're very faint, but again, it's got that arc from the Aurora oval. There's definitely Aurora band here, and then another one above it. And that's not uncommon for there to be multiple bands. Sometimes it's just a solid one. Sometimes there are multiple bands. This is the rising moon over here. I don't know, meteor. The question of meteorite or satellite or plane is always interesting, but most of the times it's satellite. But it might be meteor since I left it in the picture. Again, so in this case, the horizon is a bit obscured, so we actually can't really see that band very well, but you can see these rays or pillars rising up above, and that's definitely Aurora when you can see these rays climbing up above it. looks like a bunch of haze or maybe dust or smoke in the air that's obscuring it closer to the horizon. Again, you got the green color, and then you got the purple magenta above it. That's pretty much, I don't know of anything else that causes that color combination like that. So looking at things that are very likely to be, or something that's very likely to be confused for aurora, this is actually looking pretty much north, if I remember right. So this green here is actually not aurora. It is air glow, or sometimes called night glow, and it is produced. It's produced from oxygen just the same way as the northern lights are for that green layer, and it's produced by the same quantum effect. So it actually is the source is the same color as the aurora, which is one of the reasons it can be so confusing. It looks approximately the same color. Aurora usually has other colors mixed in with it. But air glow tends to be most visible closer to the horizon. So in some ways it has sort of the same structure as aurora, but it doesn't have that arc. It doesn't have the rays or pillars above it. It doesn't have the magenta. Like, that's quite a bit of aurora to not have magenta. This is part of the outside edge of the Milky Way. This is actually Andromeda galaxy up here. So here's another example of sky glow, actually with aurora. And the aurora was so dim I could not see that there was aurora there until I started taking pictures. So you can just see the little bit of yellow through the trees, but you can see the magenta purple above it. Sky glow can have purple in it just to make it more confusing. And then this is a time lapse, and you can see how it almost looks like clouds in the atmosphere. This is over about an hour and a half. As the Earth rotates, you can see the stars moving, but you can see that you usually have these waves in the air glow. You have these alternating red and purple bands, and then down here the aurora isn't really going anywhere, right? If anything, it goes up. In this case, the air glow seems to be moving north. Well, doesn't necessarily always do that. It's just what's happening in this case. But you can see the difference between the two. It was a little bit hazy, smoky, so the colors are pretty muted here, and it's very, very low in the horizon. The only thing I could see with my eyes was that little patch of sky was slightly brighter than it should be. And air glow you generally can't see with your eyes. It is pretty dim. It's only under the absolute best conditions with really bright air glow can you see it. These are less likely to be confused with the northern lights, but they appear in the same area. So these are noctilucent clouds. This is over Edmonton, Alberta. So these blue glowy clouds also appear in the summer months to the north. So they're in the same direction as the aurora. In fact, I think I've got a couple pictures with just a hint of aurora in here, but so they don't have the same structure. They don't have the same color, so they're definitely not aurora. They also move differently if you take pictures over time. Here's an example with both noctilucent clouds and aurora. So we got the noctilucent clouds are quite quite a bit brighter than Aurora generally. So maybe a bit overexposed noctilucent clouds. Low on the horizon, they're about 80 kilometers up, and the Aurora starts at about 100. So they will always be below the Aurora. And you can see the Aurora colors, and you can see the magenta, and it's sort of a band across the top, but this one's got more structure. This is probably a bit of a telephoto shot, just because the noctilucent clouds are very low on the horizon. You might see this. This is pretty unlikely, and it's definitely not Aurora. There's a zodiacal light. You can see this sort of light pillar that's going up. It happens around the equinoxes, and it's the wrong direction for one thing. It's in the south, but it is another thing that sort of glows in the sky near sunrise and sunset. Something that happens in winter is light pillars. That's these pillars of light shining up. Also not Aurora, just light sources on the ground reflecting off ice or snow particles in the atmosphere. Usually this happens when it's really cold, or there's just like a little bit of snow drifting down, maybe from those clouds above. That is allowing the light to bounce off the ground and straight back up and create those pillars. And you can see how much of a glow is being caught, in the clouds created by the lights. Obviously not Aurora because it's the wrong color. It doesn't have the structure, and this is actually the wrong direction. It's hard to tell from the stars unless you're really familiar with the stars, but that's the Pleiades. So that's generally south. And then if you're a little bit closer, then light pillars are really cool if you get to see them, but you need to be in fairly cold environments to get them, and just the right conditions. So that is a number of things that are and aren't the Northern Lights. So just remember, start going through a list in your head. Are you looking north? Is it dark enough? Are the colors correct? Is this yellowy green, greenish yellow, with red to magenta bands above it? Does the structure look like Aurora? Aurora has a lot of shapes, but they're pretty recognizable after a while. Is Aurora even expected in that area? Not just based on the longer 3-day forecast, the conditions can change considerably, and you can see Aurora when it's not forecast, but you should be able to tell from HPI values if the Aurora should be visible where you are, if you have done a bit of research on what auroral area you're in, or what auroral zone. And then if there's clouds, the clouds will block the Aurora, but lights underneath them will light them up. But usually the colors will be wrong, and it should be pretty obvious if the light source is coming from the ground. And if the clouds are dark enough that you can't see stars, you can't see Aurora through them either. Patchy clouds, you can see the Aurora, but then you should be able to see the colors as well. With that, please check out episode 28, What is Stellarium? And I'm wishing you clear skies and happy hunting.